In October 2025, we have released our first version of the plugin Carbon. We have spoken of it during events in France and in Brazil. Today, I'm going to show you how to set it up and take advantage of an exponential milestone on GLPI history to help companies stay aligned with CSR policies. But if you got to this video and don't really know what GLPI is an open source service management tool that allows you to scan your network looking for computers, network devices, peripherals, monitors, printers, servers, and every compatible asset to centralize information and manage their lifecycle in one place. In 2024, we joined a 3-year project called IEN in coordination with IRT System X and a joint work with partnered organizations in order to develop a reference of measurement of environmental impact of these digital services. The GLPI Carbon plugin is one of the results of this project. With GLPI Carbon, teams can collect carbon intensity of manufacturing and electricity consumed on digital services using external data sources. With this data and proper settings, your team is able to estimate consumed energy and carbon footprint of assets and digital services. But before we begin, it is important to mention that the plugin is maintained by TechLab and no subscription is needed to use it, though external data providers may have extra fees according to your localization. Once set up, the plugin Carbon will add extra tabs on supported devices, an extra report, and widgets options to dashboards. Measuring the true environmental footprint of technology, like servers, cloud usage, and hardware, is notoriously complex. GLPI already has the assets data. In order to measure carbon footprint, the research allowed us to realize that the carbon emissions do not rely only on electrical consumption, but also on fabrication and transport. For gathering reliable data and set parameters, we've chosen to use Boavizta as one of the external tools that provides carbon footprint data from assets, fabrication, and transport. Boavizta is a French non-profit organization and inter-organizational dedicated to green IT initiatives, and its mission is not only focused on greenhouse gas emissions, but also depletion of abiotic resources and primary energy consumption. Here's a glimpse of data you are going to find on Boavizta. And the tool has an API that can be consumed using a Docker image. In order to have access to this API, you will follow the instructions of Boavizta documentation and start a new local container. First of all, we are accessing the documentation of the Carbon plugin on our Hub Center, then looking for the Install Dependencies menu. Click on the Boavizta API documentation. On its documentation, we are choosing the default Docker container installation, which is going to be using the port 5000 of our server. GLPI will only need access to the URL and port 5000 of your Docker server to use this API. In my case, I have already set it up on the local host, the same server where the GLPI is installed. So I need the URL localhost 2.5000. After the container is running, we will need its address. And for sure, GLPI needs access to this URL. In this example, we are using the Electricity Maps free API key. So if you haven't created an Electricity Maps account, create it now. Electricity Maps is a real-time data visualization platform and API that tracks where the world's electricity comes from and how much CO2 or carbon is emitted to produce it. After its creation, the account, let's click on Developer Hub and copy the API key. Now, in GLPI, let's install the plugin using the marketplace. Open your GLPI instance, click on Setup, click on Plugins, then on Discover. Type Carbon, install it, click on Configure. In the plugin configuration, we are going to paste the Electricity Maps API previously copied in its field. Make sure that the impact engine is set to Boavizta, then insert the Boavizta URL, which is localhost 5000 in my case. So right now, we have in GLPI 2 external data sources from where GLPI gather fabrication, transport, primary energy and electrical consumption to produce and operate the supported services. And the work of linking this data to device models is made in GLPI. For the plugin to work properly, you will need to have this information set for every device compatible of the carbon footprint measurements. A location with a country or state field, a usage profile that is set on the carbon plugin tab, a model or a type with power consumption field, financial information enabled with entry date, delivery, or order date field. Let's come back to the GLPI. Now in dropdowns, on setup dropdowns, we will make sure that the locations have countries or states field. In this example, I'll click in Tokyo and set the country to Japan. Then the profile for assets should also be created according to your profiles. In this example, I'll make sure that the always-on profile is correctly set. We will create a model or a type. In this example, I will use the Optiplex 7020 computer model and make sure it has a power consumption set. After creating the dropdowns, all of them, I come back to every asset and on the Management tab of this asset, I will add a startup date or a delivery date. In this example, I'll set everything to January 1st of this same year, 2026. On the Main tab, in this case computer, I'll set the computer model of created Optiplex Micro 7020, click Save, and on the Environmental Impact tab, I will check the list of requirements and I'll also set the proper usage profile to, in this case, always on. After I click Save, I can check if all the requirements are in green or yellow and click on Calculate Data. After I do this to all devices, I will be able to see general reports of my compatible fleet clicking on Tools, Carbon Reports. The first line is all regarding the amount of carbon dioxide emissions that would have an equivalent effect on a specified key measure of climate change. The CO2 equivalent emissions are commonly used to compare emissions of different greenhouse gases. So here we have the carbon equivalent of energy consumed and embodied emission. When I say embodied, don't think about consumption, but think at fabrication of that asset. The embodied primarily energy that comes from natural resources before any conversion or transformation, like all the metals and gases emitted to have energy getting to your assets. And also here, the embodied and used abiotic depletion potential, which is the evaluation of non-renewable resources in antimony equivalent. In the end, there's a pie where admins may check what are the asset models emitting more carbon equivalent, and also a chart where it's possible to analyze the relation between consumed energy and carbon equivalent emitted.